So hello everyone. Thank you so much, Dean, for joining me in this informal podcast talk. Like this video is a bit special because of my next guest, which you will see soon. He has achieved a lot of things, and actually, if you scroll through his LinkedIn page, the list just goes on and on and on. Currently, he's working at Google as data science lead, and he will be joining us from his Google office in Singapore. So I'm happy to introduce to you guys Dean Wang. Hi, Dean. How is it going?
Hello. Hi, everyone. Happy to be here. Things are going well. We are starting to coming back to the office. I think I'm one of the 3 persons on this floor right now, but good to be back.
Okay. How long have you been since you go back to your office? Do you now go to your office every day or?
No. We started work from home since March, and we only started to coming back to office, let's say 3-4 weeks ago. Now we are in a 6-day rotation, like 1 in 6 days you can come back to the office.
Okay, yeah. I think things are going better in Singapore. I see from the news.
Yeah. But a little bit cautious will never hurt. So hopefully we can keep it this way.
Yeah. Hope same as well for people here in Australia. So Dean, do you mind telling us about yourself, just in general, brief introduction?
Sure, happy to. So I'm Dean. I'm in Singapore. I work for Google. So I had my PhD in operation research from Nanyang Technological University in Singapore about 10 years ago. And after that, I decided to not stay in academia, but to join the industry. So my first job was with Apple as their demand forecaster. And then after 1-2 years, I joined SAP as a data scientist. So we started to do more of a machine learning type of application development. Then McKinsey found me. I joined McKinsey, started an exciting journey as a data science consultant. And I spent 5 years there. I served all types of clients. I also managed to help McKinsey acquire an AI company called Quantum Black. Now we have this Quantum Black in Singapore, in Japan as well. And then last year, I joined Google as their data science lead. So it brought me here.
And you did your undergraduate and both your undergraduate and your postgraduate studies at NTU. So if I'm not mistaken, you did your undergraduate majoring in computer engineering, and you did your PhD in operational research. So maybe what was the motivation? Have you always behind choosing those 2 majors? Have you always had interest in those 2 disciplines?
So I came to Singapore under a scholarship. So I was born in China. So when I was in my high school, Singapore government have this opportunity to take us into exam, and we pass, we get the scholarship and come to Singapore. So and when we chose our major, so even back in the days when I was in high school, I'm very interested in math. So I was in all type of math competitions like Olympiads or mathematical modeling competitions. So I'm really interested. I found myself more interested in mathematical modeling than the theoretical math type of competition. So when I chose my major for my undergraduate, I actually chose between theoretical math or statistics against computer science, computer engineering. At that time, actually, for NTU, computer science and computer engineering are in the same school. They didn't separate engineering with science. So I chose the computer engineering, where I believe there's a more like application of it. Like I can use math in a broader sense. And I didn't stop like learning about math or statistics knowledges even outside my coursework. But when I started to, so after undergraduate, the thing is that I found out with a bachelor degree in computer engineering or computer science, most likely I'll become a programmer if I join the industry back then. And I'm not 100% motivated to become a computer, like a programmer at that time. So I want to do a more advanced degree. And of course, I want to pursue my dream in using math as well. But I think at that time, it is a little bit too late for me to really go back to theoretical math because I don't really studied it for like 4 years. So I was talking to a lot of professors in different universities, and I found Prof. Law in NTU. Actually, he's from a different school. He's from the School of EEE, Electronic Engineering, but he actually is from a math background, and all his like programs is around how do we use math to design a better circuit or to optimize computer networks. So I choose to do this. It is more of a operational research problem in the context of a wireless network. So basically, I need to use either the signal strength or the mobility pattern within a mobile ad hoc network to ensure the network is connected. So that's the operation research part of it. And of course, while we do this, we need to minimize the energy consumption and everything. So it is very much an optimization problem with certain constraints. So I think that's the reason why I choose to do this in my PhD. I found it is quite interesting because I get to fully use my undergraduate computer engineering type of skills to do the simulation or computational programs. But I also get to do a lot of like work in math to derive the certain equation or expected value and use simulation to verify it. So it is actually a quite fun topic to study for the 4 years I do PhD.
So there was definitely a lot of maths involved during your undergraduate studies and your PhD. So in a way, it's applied maths, and you get to actually apply it to a real world situation, which I think is important as well. And then like now you're working in the world of data science. So in fact, it's not some alien domain for you because you've been working in data science for I think more than 8 years now. So like, was it something like how did it start at the first place? And like, what was it? Was it something that you've always been interested in as well, data science in general?
Actually, it's a good continuation with my like story of PhD because back then we don't really have the term of data science. Maybe I'm old, but 10 years ago, data science is not something that people talk every day, day to day, or consider as a profession. So when I finish my PhD, I don't think I want to stay in academia because, in operation research, there is a lot of like assumptions, so you can optimize around things, right? So I found it in a conference I joined, like every workshop starts with like, what's our assumption? And I should say maybe 8 out of the 10 workshops, the assumptions are just not real. Like you can never find yourself in such an ideal situation to make use of the algorithm. So I was a little bit discouraged to see like, although operation research is already, as you said, the application side of math, it don't really get used in real life that much. So I was trying to find some area that I can use my mathematical and programming skills to solve like real life problems. And very luckily, I joined Apple as their demand planner. So I don't think at that time they realize or they call this type of job data science. But if the same scope is put down today, it will be a data analyst or data scientist job because originally they were using a lot of like empirical method or experience-driven method to forecast the demand of different products and the different market. But we find that we can actually use statistical model to do that. And you at least have some theory to back it up when you have a forecast of certain amount that is different from the empirical thing. And what is also amazing is that I should say Steve Jobs is really a visionary because he actually collected a lot of historical data in the past for Apple products. So we can actually build a decent machine learning model from the past demand and to predict the future demand. But still, at that job, we were not calling it data science. We call it the demand planner. We call it forecaster. But I get a sense that a lot of like theory can be used in reality to solve real problems. I think it is at around a similar time people start to talk about big data. People start to talk about data science, and I realized what I'm doing is actually a very fine branch of data science, which is demand forecasting. And I started to learn more things. Like I realized the R programming tool I used in my PhD is actually the data science tool a lot of people use. So it's very natural for me to pick up more skills in this area and try to think of like other area of using the data science to solve. So I think unlike a lot of like people now who always want to be a data scientist and try to be one, I was like, I started to do data science and I then realized, I become a data scientist back then. But that was like almost 10 years ago. I think now we are fortunate enough to have a lot of resources to learn this and to understand what it does mean to become a data scientist.
So you mentioned that you've been working in data science for quite some time, like 8 years, more than 8 years. And have you ever thought about like moving on from data science, or actually, does it actually make you want to study data science even further?
I think maybe there are two things or three things I have learned in my journey in data science. First of all, I think data science, the whole scope of data science is become wider and wider. So I think when I first started to learn data science or become a data scientist, anything related to data seems to be data scientist job. For example, when I first joined McKinsey, I think my job scope is whenever there is a data file that people can't open using Excel, they will feel this is data scientist job to analyze that data file. But then like people start to realize it's actually a very wide area that needs more than one role to perform the different tasks. So there will be data engineers, there will be machine learning engineers, there will be product managers, there will be even sales data science consultants to help people understand the problem. So the world of data scientists is become wider and wider in my past few years. So when I think of my career, I definitely want to stay in the space of data science, but maybe the role I want to play started to shift to different places. So as I said, I started from a very theoretical, even research background on using data science, using operational research to optimize things. So it will be on a very research end. But gradually, I found that I'm also comfortable to present this idea in front of people. I'm also comfortable to develop solutions out of like theoretical researches. So I'm happy to move to another end of the spectrum where more like people interaction or even sales type of tasks. So I think I'm exploring in this spectrum where it's more suitable for me, that I can contribute all my skills and also satisfy all my interest. So for me, it can be research, it can be, let's say, engineering or making a data science solution into product, or it can be like a consulting, like using this product to solve real life problem or make revenue out of this kind of data science solution. So this is one. So while I say I still want to be in the world of data science, my role may shift in this spectrum. And second is that I do feel it is a very quickly evolving industry in data science. Like the new things are coming out every year. Like maybe 2 years ago, it's about deep learning, it's about TensorFlow. This year is about the GPT-3. It's about automated language processing, and maybe next year it's about like automated pipeline or decision making or some new breakthrough in image processing. So to catch up with this kind of trends actually requires a lot of effort, and the experience you have collected in the past few years may not be helpful for you to pick up the new algorithm or new trend. So I think for anyone who is developing a career in data science, need to think like, what would be the most sensible next step that you make based on your past history or past experience. If we have to learn new algorithms every year or every few months, I actually don't think it is a sustainable career. So I tend to be like, so for many of these new things, I'm staying in a relatively higher level to understand what these new solutions can do and can't do. But I don't really try to learn all the hands-on details of the new things. Only when it becomes relevant to my work, I'm happy to learn. But we have to give up some of the new things just because it's less relevant to the day-to-day work. So this is two. And the third thing is that data science is used everywhere, right? It's not only in demand forecasting, it's not only in certain industries, it's actually in all the kinds of industries. So my experience in McKinsey is like, maybe 2 weeks ago, I was serving a bank on their churn model. And 2 weeks later, I will be serving, let's say, oil field in their predictive maintenance. And then I will serve a tech company on their talent retention type of problem. So there will be a lot of different problems and challenges that data science are trying to solve. So as data scientists, I think it has become more and more important to see where and how you link your data science skills and knowledge to certain industrial expertise or industrial areas that creates the value. So I don't think anyone can become a really successful data scientist without any focus in particular industry. I believe that it takes a lot of effort to narrow it down to a smaller scope or a particular area of data science to make it successful. So when I say I still want to continue to be a data scientist, I continue to learn data science. I think these are the three things I think about. Like, I will be trying different roles. I will be picking up the skills at the right level, and I will be limiting the scope of my work to some area that is more relevant.
That's actually a very insightful answer, and I think it actually got me thinking. Like, onto my next question, actually, because you've had a lot of experiences like along the way with Apple, and then you move on to McKinsey, and then like until now at Google. Like, what do you think are the lessons or important values that you learn along the way?
I think each role offers me a new perspective of the work I do, as well as the world or the value that I can bring to the world. So I think in Apple, I really get to see what is like to work for a top class company, right? How people are trying to achieve their different goals, how they are using like cutting edge technology to build successful commercial product. So I think that is, and as my first job, I think that's quite ideal for me to learn about basically how to work, how does a company works, how to work in a team. So that's definitely a good thing. And then I joined SAP. SAP is a German company. So a lot of things are very solid, are very Germany. And I actually enjoyed that because a clear defined scope and a clear defined goal, I think it is fundamental for success. So, and also that is, SAP is one of the first few companies trying to push like industrial-wide machine learning applications. And that is really exciting. I get to work in a lot of like exciting projects. One of the most fun projects I have worked with on this, we actually helped the German soccer teams to optimize their strategy. And I think some of our algorithm and fundamental eventually get to use with German soccer team in 2014 World Cup, and they actually won. So that's actually a very exciting journey. And it also gives me the exposure saying another side of data science is besides building the algorithm, making the code, another side of data science is really telling the story. Like how do you package your analytics, your insights into a story, and other people are interested in learning and knowing about it. So I started to do that in SAP, and I found that I'm actually very passionate and motivated by that. So when McKinsey opportunity comes along, it's a very natural decision for me to join McKinsey. And as I said, McKinsey, I think the best thing in McKinsey is that you get to learn different things. Like you get to expose to all kinds of industry, all kinds of weird problems, and all kinds of people. So I get to see a lot of the different type of companies and different way of thinking. And it also brought me to different places in the world. I traveled I think in 2018, I took 100 flights within a year and a flight for 400 hours. So that really like means a lot of like new things to me. But that's actually also the fundamental reason I left McKinsey, because of the lifestyle. So now within Google, I think again it's almost like a circle. Like I come back to see like how people are making use of analytics and the technology to achieve commercial success. I think Google is the best example to combine commercial and the technology, right? So how did the Google manage to do this translation or do this value creation is something I'm very interested in learning, and I believe this success can be transferable to other industries or to other roles as well. So I think I'm also learning a lot here. So I think so when I joined each of these companies, I didn't really made up my mind that these are the particular things I want to learn from this job. But I tend to have a very open mind to see how it takes me. So after a few years or after I worked for them, when I reflect, I can always see, oh, this is actually something new that I have learned, and I'm always happy that I can pick these things up along the way.
Very interesting. And now you mentioned SAP, and then you mentioned how you helped the analytics team to help Germany win the World Cup. That's very interesting to me. Like, I mean, I've never thought that you can actually employ that kind of things, like two different things, that two seemingly different, unrelated topics to each other. And yeah, it's just very fascinating to me that, yeah, I mean, you were part of the World Cup. I mean, Germany's involvement in the World Cup until they won the World Cup 2014. I think, yeah, it was 2014. And then like I noticed that you also, I mean, during your work in McKinsey, you also sometimes gave lectures. I think you are still giving lectures, speak at you're giving talks. I mean, yeah, I mean, that's something. I mean, I would think of it as like, you know, going back to academia in a way. I mean, like, do you would you be like, I don't know, working in academia entice you?
I like to share. I like to share my thoughts. I wouldn't say it is strictly teaching, but I do feel my experience in data science and also in the industry could be interesting for many of the students. So I'm always open and happy to share this kind of thing in different kinds of forums. Either it is a lecture in university or it is more of a panel discussion in some events. So I'm always happy to share this. I don't think I will go back to academia to teach and research as a strictly saying data scientist or researcher or mathematician. I think I have already like given up that after I left my PhD. So but I do think I can add value in the other side of the story is to how do we really use of this. To be honest, I think even when we look at like the current trend of talents, people are always saying that we have a big gap of data scientists, right, in all the industries. Maybe let's say 20% of the positions are not filled in the field of data science. I believe that's true, but I also feel there could be an even bigger gap in terms of how it relates the value of data science into a business value. And a lot of people haven't really realized that. For data science, of course, we lack of talent, but look at what our university is doing, right? Not even university, there are students learning like data science and coding in high school. Even in secondary school, people start learning that. So I believe in a few years' time, saying that you know how to use Python to do regression is like now you're saying you know how to make a table in Excel. So data science is really, the skill of data science will be commoditized really soon. But the real thing adds value is to know what type of analytics is really needed for certain type of business and creates value for that. So I feel like I can actually share my experience in that and help a lot of people to bridge in that gap. So I do feel there's a lot of opportunities people can do better in that sense, and I'm happy to share my thoughts on that as well.
It's actually interesting, and I will get back to you about that. I think I will probably relate more about like people from maths background later on. But before I get onto that, I think I'm curious actually, because you're now working at Google. Like, maybe one question for me is how is it like working at Google?
Google. So I spent a lot of time working for Google from home. I would say that experience is actually very different than working from Google in a Google office. Of course, if anyone who ever visited any Google office, I think the first impressive thing is it's a very open space. It feels like a space to do new things, and you will be excited by the surrounding, and it has nice free food for your every meal. So I think that's actually quite important. I think for Google, one thing is that it is very much an engineer-driven company. Not only saying that in their product or in their research, it's engineering-driven in the sense that they aim to build the best product and they try to satisfy the users. Also, even in their sales team, people are trying to thinking from an engineer point of view to see how do they improve their product, improve their service, so that the client can be served better. So it's very like result and outcome impact oriented. So I think that's the first thing. And second thing is that it's a really open environment, not to say just the hardware and everything. It's also like interpersonal relationship is very open. You can actually book a coffee drink with anyone you can find in the directory. So if their time is available, most of the people are happy to have a coffee chat with you to learn what you are doing and how you can work together. I think 80% of my work is actually discussed over coffee drinks or like just like casual like catch-ups. So I think that's definitely a good thing. And also, it's a very global company, meaning you get to work with people all around the world. Sometimes people, let's say in Israel, will reach out to you to see if they can adopt your solution. Sometimes you will call someone in Iceland to understand what they are doing on their perspective. As long as the time difference works, it is fine. And also, to do this, most of the people have their calendar open, meaning that you can actually slot in a meeting with anyone as long as the calendar is not filled up. So one of the few things I learned in Google is you get to manage your calendar before someone else manages it. So if you really want to, let's say, build a model in that 2 hours, you'd better put a blocker in your calendar saying that that's your busy hour. Otherwise, it will be super filled up by like coffee drinks and catch-ups. So I think that's actually a fun way to work, and gives you a lot of exposure to interesting people and things. And third thing is I think it's a really responsible company. Like we deal with data and we deal with very sensitive data time to time, but the standard of security and the standard of policy is really high, and I feel a lot of respect in this area. Like we do, like this is not something just on paper or people talk about. This is in day-to-day life. We need to make like good decisions to do this right. So I do feel like everyone in Google I see is playing good responsibility to do this.
Sounds like it's a company that promotes or encourages like exchange of ideas, and I think it's a very interesting and nice. It would be nice to work in that kind of environment for me personally. Yeah.
But this may not be unique to Google, right? So I think the important thing is that we create this kind of atmosphere in wherever we work, or at least when you deal with anyone that works with you, either they are a colleague or they are a collaborator outside, or in your new company or whatever. I think data scientists or any people interested in tech should be having a like open mind of sharing and collaborating.
Yeah, I agree with you. Okay, let's actually talk about maths, something that you mentioned earlier. So I come from a maths background, and I must admit that I'm not very well versed in the world of data science. I know some ideas about it, but I'm not an expert in that area. So in your opinion, like what benefit do people from maths or maybe data background have when entering data science?
So I have shared this in a few forums. Like ideal data scientists in my mind have three areas of skills. So one is math, and one is computer science, like programming, and another one is communication. So I think a good data scientist need to have all three as much as possible to be successful. So if we talk from the math perspective, I think what math can offer are twofold. One is the knowledge. Like there are actually a lot of data science relies on the underlying math operation to make things valid. Think of the simplest thing. I don't think a lot of data scientists can even explain the value, the meaning of p-value nowadays. So this is a very small area of math, right? But not a lot of data scientists have that kind of a knowledge foundation to explain that. But I do believe someone who can understand the p-value or understand the math behind it would be better suited to solve problems using any statistical method. So I think that's a relationship between math or statistics with data science. It's a foundation. It's a good thing to have when you want to do like deeper things. And not just the statistics, there's a lot of like a matrix operation, even in deep mind, in neural network, in deep learning. So if we just take a computer programmer to do that, they may be able to deploy that package. They wouldn't understand this kind of matrices operations. Then they would not understand what is the limitation of using such operation or what can go actually wrong. A lot of time I see people tune the parameter or train the model mostly like a trial and error thing, right? To just wait for a good outcome to show up. But I think from a math background, we can actually tune the model in a better way because we understand how it works. So it is almost like a computer engineer is more like a driver who can drive a good car and maybe very fast. But mathematicians are actually the mechanics to really repair the car or improve the car, and fundamentally people can drive it better. So I think that's one. And the second one, I think for math, for anyone from a math background, especially if you are from a research type of math background, it is important in data science to understand how to do research and how to do experiments and what's a way to extend your solution. So I do feel, I wouldn't say like to be a data scientist, someone need to be a PhD or what, but I do feel if someone understands how to do experiments, how to design experiments, how to verify hypotheses, would be super helpful if he or she want to be a data scientist. So I think this is also something coming from maybe the math, maybe easier from the math background. Like we know how do we try an idea and how do we pivot from the idea to other like workable solutions, right? So this is actually in sense an essential thing in the data science world as well. So it is not just the knowledge, but also the way of thinking would be helpful.
Yeah, it's interesting because there is, I think there is like a conception that like data scientists like you will eventually become like coders or software engineers, and I think there are a lot of like options or spaces for people who have a coming from maths background to fill. Like so okay, maybe like do you think like with people like coming from maths background, like do you think there are a lot of things we can certainly do to fill the gap, to fill the space?
Well, I don't think this will come naturally like from anyone. It is more like you can actually steer your career to certain directions that you feel like better suited to you. I know a lot of like my friends who work in the math space actually are actively learning coding to become more like a data scientist, or even in their own research, they need to do a lot of like simulations, which is naturally bring them to the space of computer engineering as well. So I think this will certainly fill some of the gaps between a mathematician and a data scientist. But the other thing is, it's not only apply to mathematicians or mathematics students. It applies to a lot of people who are in the data science space. Is how do they learn about the industry, or how do they get exposure to the business problems? This would be an even bigger challenge. So compared to for a mathematician to learn coding, I think that's not easy, but that's manageable, or there's a certain way you can do certain course and learn about it. But if you want to learn, like how do you tell a good story? How do you translate your research into good business sense? It's not something easily trainable, right? It is more like you need to figure it out along the way by reading a lot of stories, by talking to a lot of people, or even through yourself in the business world and get it tried out. I would say that is more difficult, but the reward is also quite good, right? So you get to experience a lot of new things. So I would say not just the mathematics students, so everyone who want to be in the world of data science or with certain like degree in the beginning of data science career need to have an open mind to try different things, to learn things. To become a good data scientist or to understand the business side of data science, it's not something you can read from book or read from reports. You get to apply it somewhere and discuss with people. Like for me, I used to think like data science forecasting is just forecasting. Classification is just basically you generate a good AUC curve, that's all. But when I actually do some of the, let's say, predict maintenance problem, you get to see that the confusion matrix actually get to translate into different kind of cost because of the business. And the way you want to fine-tune your model is no longer just to get an optimal AUC. It is how do you tune the confusion matrix to minimize the cost. So the problem actually gets transformed along the way. So to get this kind of sense, you can only do it after you have tried it in real life. So there is a lot of like a practical training that people need to go through to really do that. So I think that would be the most important thing to fill in the gaps.
Yeah, very insightful, discussion, we have here, and I believe the viewers will feel the same too as me. Like I gain a lot of things just listening to your story and experiences, Dean. And maybe to finish it off, maybe I will probably ask something like a bit personal, like what do you do in your spare time, for example? Do you have any interests?
Yeah, I like building Lego.
Building Lego.
Both with my son on the simpler one, or by myself to build more the mechanical or programmable ones. So I really enjoy building that. I just finished the Saturn V rocket with my son. I'm trying to build more the programmable robot using different components. So hopefully one day I can build some working robot to help me to do some of the houseworks as well. That's my dream. And I like watch football. So you know how excited I was when I worked for the German soccer team and found out that they win the World Cup. But it's actually a funny story. So because I like football that much, I have my understanding of football games. Like I have my sense like what is good and what is bad. This actually didn't really help me when I build those models for like football analytics, because this kind of understandings would not always be reflected by the insights from the model, and you don't really get to work in this kind of exciting area. Like, of course, I want to build a model to predict how do we win the match, right? But actually, what we build maybe is an injury prediction algorithm to see how do we analyze the training and the testing data to see if a player would get injured. Actually, this creates a lot of impact, but as a football fan, you would want to say that, okay, I build a model to see whether they can score a goal in the next 10 minutes. So there's always this kind of gap. And the next thing is that I found that when I work for football, work on the like football analytics, I can't really watch the game with a peaceful mind. Like I'm always thinking, what kind of data can we capture here? Is this kind of situation reflected in the data we captured? How do we actually use the data to reflect the change in the field? So I become like more nervous when I watch games and think too much. And that it actually took me quite a long time to like to get back to a normal football fan, just to have fun and watch the games. So it has, while the project is so exciting and interesting, it has its trade-offs when you mix up your personal interest with the work you do. So yeah, but again, if there's another football club or football team that ask me to help them build some model, I would say yes, I would still want to do that, because that's actually something really interesting to do. So yeah, I think that's pretty. Of course, I want to. I would love to spend time with my son, and this is another thing, right? So even my son is 7 years old, and they are starting to learn programming, and I was that's another reason I'm thinking like, whatever I learn maybe in university will be known to some primary school student in the next few years. So we'll have to move fast to learn something new as well.
I'm just curious, maybe because you mentioned that your son currently learning programming. Like, what kind of approach would you think is the best to introduce programming to like children?
Of course, games and rewards.
Mm,
Like
mm,
I don't really have to motivate my son in learning programming. He would actually naturally be very interested if he finds that it is actually a game of something he's really interested in. My son is really interested in one of the cartoons called Number Blocks, which they made each of number as a cartoon character. I think my son is a geek, so he's interested in this kind of thing. So if I show him he can actually make a game using this kind of character, he would love to like play it around. And people are making programming so easy right now, right? So they can use Scratch to do it. So basically, it's a drag and drop, like a modularized coding base, and he can control all the characters that he can created. So what I need to do is I need to explain to him, like if he want to do this, what are the steps he need to do, and he will remember, and the next time he actually knows how to do it. And he want to create new things, he will, like the first time it will be a linear thing, like okay, this number walks from here to that, there, and maybe like dropped into a hole, something like that. The next time he will be like, okay, can we make a for loop to make things repeatedly drop into the same hole, and he feels that funny. So I don't want to set any target like what he need to learn or what he need to achieve. I just want him to have some fun and do whatever he want to do. And I feel it's already a lot of things he can learn from that perspective. Of course, if one day like programming become one of his like subject in school, maybe the approach need to be different. Like we need to be following certain like modules, following certain structure to learn. But now, for 7 years old, I'm pretty happy with like he trying out whatever he's interested in.
Yeah. Wow, very interesting. All right. Okay. Thank you so much, Dean. And maybe to finish it off, just one last question from me. Like, what advice would you give to people who want to pursue data science or consider data science as their career?
Yeah, if it's just one advice, I would say have an open mind. Like, don't really think data science as a narrow or a limited scope thing. Like, don't feel like I have to be very successful programmer or mathematician to become a data scientist. There are actually a lot of the things we can do in the world of data science, and most of them requires different type of skills. So maybe it takes me back to the spectrum I was talking about, right? So data science is really from research to business, and there's a lot of things happens in between. So anyone who want to pursue a data science career wouldn't be able to cover the whole spectrum. So we need to narrow ourselves down to certain parts of it and work towards that particular direction. So if you are good in math, if you enjoy like doing research, of course you can work in the research end of the spectrum to invent new algorithms or invent new things out of it. If you are more happy with, let's say, coding or make things work, I think engineering or building product would be more suitable for you. And if you are more interested in creating business impact, then maybe you can do product management with analytical projects. And if you are really interested in like interpersonal skills or create a business opportunity, so you can actually become a data science consultant, or you can be a salespeople for data science products. So I don't think there is only one way to become successful in data science. And if anyone want to step into the career of data science, I will encourage them to have an open mind and try different things. You'll never know which role in this spectrum would be the most suitable for you, right? So yeah, getting like understanding all this and trying out different things, I think would be the best thing we can do now.
Oh, all right. That's a good one, because and it actually motivates me to learn more about data science. I mean, you mentioned that if I am say one is interested in the research end of data science, one can just focus on that. You you don't, in a way, don't have to be good at coding as well. Like, you can just focus at your research experience. Maybe a good coding skill will probably help, but you don't have to have like a very high coding skill for you to enter the world of data science. And it will like you know as you have more experience, you will have more exposure in different areas as well, and that's actually true. Yeah.
Yeah. So I think the entry point for data science is it's becoming lower than before. Like a lot of people with less experience can start to become can start to learn about data science already. And with a mathematical background, I think a lot of people are already way ahead of others in the sense of understanding the numbers, or at least be friend of the numbers, right? Feel comfortable around the numbers. So yeah, people with mathematical background are really like have a good chance to do that if people are if you are motivated.
All right. Okay. Thank you so much, Dean, for participating, agreeing to talk to us. I mean, I'm sure, at least for me, it gives me a lot of insights about the world of data science, and I'm hoping that the viewers feel the same way as well. So thank you so much, Dean, for your insights.
Welcome, keep in touch, and all the best. Stay safe.
Okay.